2, 1.
3, 2, 1.
Mask or no mask?
We're 6 feet apart.
I think we're 6 feet.
Yeah.
We'll take the mask off. Ah! Oh, I scared the people back at home when I took the mask off. I heard the screams all the way from here. How's everybody doing? JP and I have decided to have fun this morning. To heck with it. So, guys, this is going to be the third part, the final, on that 6S that they were testing with the overhead CTs. And so we'll be talking about that one today. I'll kind of give you a warm-up of what we ran into previous up to this. Here's the schedule upcoming for us. We are, of course, like I said, finishing up that part 3 on that. Next week, we will be doing that load boost benchtop test redo that I was asked by some folks at a couple of meter schools to redo it so you can see the connections better. And then it turns out, now I've got the full story. At first, I was going to give him a little bit of a hard time about taking so much time off. But now that I found out it is his wedding anniversary, I found out that JP is a smart man. So JP is going to take his lovely bride, who I've met, by the way, and he's going to take his bride to Flagstaff. That's going to be awesome. That's going to take him back memory lane and everything. Whereas to the mountain his son was there, everything. It's going to be an awesome trip. So we're going to take a break there. So it's going to be a good time when we hit October because we will have just finished out this one, the 6S. We will do the load boost test for the folks. Then the 5th, 12th, and 19th, we won't be having webinars. This will give you a chance to get caught up. If on any of the ones you missed before, you can look at those. Of course, you can go on YouTube or on our website and look at any of these that we're doing. So you could preview and look at that stuff. So we'll be starting back up right after that, and we'll be starting out with a new site. And just as we've been doing before, we'll do 3 of them and complete the entire site. We'll do the inspection part of it, the initial hooking up and testing, and then the actual results of the test. It's how we've kind of been dividing them up. So we'll do that again, and we'll start a new one the week after so it'll be the 26th. Mm-hmm. So we'll start October 26th. We will start up with a new site. So we'll finish up the site today. Next time will be the requested load boost benchtop test, and then we will take a hiatus for 3. And then we'll be right back on the 26th with starting a new site. Okay, agenda. So today we're going to do a quick review to bring us up to speed where we are on this last one of this 6S site. And we talk about using the hot stick up there, make some good points on hot stick, and testing the CTs up there. There's a lot of chances for troubleshooting here. This site had issues. So we're going to talk about some of the tips we've had, some tricks, and then kind of the total solution after we're done. So this is a really great site to learn some things. So we're excited about the finish of this because you get to see how we solved the problem and what happened. So it's pretty good stuff. Oh yeah, we already talked about that. Cool. Okay. Had some requests this morning, and it just reminded me of something. If anybody ever wants me to pray for anything, please send it into the chat room. I got asked by some folks this morning to pray, and so for folks they know, and that it is a privilege to pray for someone. So I would, if anyone has anything they would like for me to pray about, please send it in the chat room. Like I said, I had some requests this week. So I'm a very good friend of the Powermetrix family. One of our reps, his mother, has come down with COVID, and she's not in good shape at all. So we will definitely be praying for John's mom. And we're also going to give some thanks for one of our own folks that now is on the other side of it. Had a rough time for a while, but he's on the other side of it now. So he seems to be doing a lot better. He's on the road to recovery, so we'll give some thanks for that. So let's go ahead and pray, and then we'll get started on the 6S site today, okay? All right. Father, it's those times right now that's we've chosen the the narrow path, and we've chosen that narrow path, and so we're trying to live according to what you tell us and follow your word and talk to you as much as we can in prayer, and then come alongside other Christians and talk with them and work through things with them. And Father, this is where it's tough because we got a Christian brother whose mother's in really bad shape right now. Just hit him and bam, and they find her and she's in bad shape. And Lord, it's just, it's these things in life is where it really, really comes to bear to us as Christians that you are You are the source of comfort. You do have all the answers to everything. You are the creator of the universe. So, Father, thank you so much for the comfort you can give us. Please, Father, try and give comfort to our brother John and guide the doctors and be there with his mother. And Father, also thank you so much for what you did for our brother and got him through things. And he had some tough days there in the hospital. But Steve's doing fine now, and we're so happy for that and so thankful and give you all the praise and all the glory for all of it, Lord, because we're all praying for him. So, Lord, just be there with John and his mom, and thank you so much for this time today. And as we say, Lord, it's so much more important, the safety of what we're doing here versus trying to sell anything, because we're not. If there's anything we can show someone today that'll keep them from getting in trouble out there in the field, please, please let that be brought to my mind and let me say it. So thank you so much for today. Thank you so much for the opportunity to do this. And I just thank you for another day here, Lord, because we just shouldn't take that for granted. So thank you. So all of these things I ask and say, according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Cool. So we ready to roll this thing?
Ready to go?
All right, kick it, JP. Oh, sorry. I need to do a little review. I should say where we are. But JP has even made his process even better now, so he's quicker on the draw. He's changed some things now on how he runs it. So, real quick, this was a 6S site. Remember, it was there were really there's 2 metered installations there. There was a granite cutting and then the offices for it. Over on the offices, we did notice that we didn't have a lot of load. There wasn't much going on in there. We could tell, okay? But when we first started when we first connected up, opened it up and did our inspections, we noticed a lot of grass and even a rock and stuff behind the test switch. I was noticing some arcing behind the test switch, so I pointed that out, and so we knew that we probably were going to have some issues getting some good tests. And sure enough, remember when we hooked everything up, what we saw, which was very unusual, was if you get ready to do your meter test, you do a customer load test, you test your meter and you think meter's fine, so everything's good. Remember, the meter only tests what it sees. Okay, it's kind of that we say garbage in, garbage out. So whatever that meter sees, it just wants to tell you how accurate what it's seeing is. But it might not be seeing everything it should. And we've seen this before on tests, right? Where you can even have polarity reversal on one phase and the meter tests out fine. Because what the meter's seeing and getting, that is accurate. But we're missing, we've got one phase canceling out another. We're only getting really one phase coming through there. But on that one phase, it's accurate. Well, that's why we have to test the CTs and really look at things on the CT side of it. Okay, because that's where we can get these major issues, okay? So now when we get over there, we noticed the meter tested fine, but we were noticing some numbers we didn't like, really low numbers here, okay? So now we're going to get into the CT test of it, and here's where it all really comes to bear, and we're going to start putting all the pieces together. So remember, we've already seen some things we didn't like, okay? So as we go through this, we're really going to take our time and troubleshoot it, and unfortunately, I'm going to make JP stop a few times, but we're going to really go through this thing, okay? So let's do it.
So if you can just set that up on a pole for a second. Let's talk about something real quick. There you go. Okay, so
now I don't know if anybody remembers or not, but when we were also at this site initially in that very first one, we noticed harmonics. Okay, we saw harmonics on when we looked. Remember, you have those hot buttons, so you can take a look at things. If you go back to the first part of this series, you'll remember when we looked down there, we noticed harmonics. Down there we have total harmonic distortion, voltage or current at the bottom of the screen on that RMS table screen where it gives you all the information. And we noticed harmonics. Well, JP just let me in on a cool fact of when you hear that, you hear the buzzing and things that you're hearing right here on the audio, that's harmonics. So it all plays out. We actually saw it on our equipment too. So, thanks.
let's say, and we've talked about this in the on the webinars before. So Browland's out here, and let's say he doesn't know what's A, B, or C phases, right? So when he gets ready to run the test, when he puts this on here, for him to find out which is A, B, or C, he'll be able to find out by when he runs the test. If it gives him a cross phase, he'll know he's not on the correct phase. So we're going to go ahead and I'm going to let him get up there and get on one of them, and I'm going to hit start test on here. So when you put one of them on there, what are you thinking about when you go to put that thing on there?
You always want to remember the label on the fork toward the load.
Perfect. Label towards the load. Remember the two L's. Label towards the load. So you can see that. You can see up there at the top. You can see the label. The label on the front of that thing. You can see the label is going towards the load. And you see the label he's got over here on his right side. And that's where it's going down the pole there, right? To the customer. All right, cool. So we've got label towards the load. And he's got it around both conductors there. Looks good. You want to try and get it as deep as possible, right? Because you got a little sweet spot in there. That line that we talk about in the webinars, that line across there on the high volt, you want to be below that. So you want it to be as close as you can, bottomed it out, which is what he's got. So he's going to try and bottom it out as much as possible. Okay?
Okay, so remember what we just said there. You definitely do want to bottom it out, and it's able towards the load, okay? So when you get in there, if you've got more than one conductor running there, you got to watch it because you might grab one and it's in there deep enough, but you'll have one that's not, okay? So you'll hear me in a second here, coach them a little bit. I was saying catch where they cross, because where they're crossing, I know I can get both of them deep up in the high volt probe right there in my horseshoe, okay? So if the label towards the load to make sure you don't get polarity reversal on it, but also you want to make sure you get it up in there deep, and you want, if you got two conductors, you want to get them both in there. If you grab the one and the other one's too high up in there and it's sitting outside of my sweet spot, okay, then that could cause me problems. I'm not picking up all that primary current that I should, okay?
So that one conductor, so you're on both of those conductors, right? So if you can, you kind of almost, let me ask you a question, to get both of them in there, that one conductor's, yeah, that's what I was wondering. Can you get both of them in there better like that? Let's try that and see. All right, I like that and better. Okay, all right, let's try this. So I'm gonna go ahead and hit. I'm gonna come over here to the machine and hit and start the test.
And also notice while he's up there making his connections, you want to have your horseshoe or the high volt probe perpendicular to the conductor if you can. You don't want to have it lay over and be running alongside the conductors. You want it to be perpendicular to them. You can see that's the way he's doing it up there.
On the primary A, and then a green open circle for B and C, which is telling you you're going to have to move the probe. You're only using one, and you're going to have to move it to B and then to C. If you had 3 flexes on there, they'd all be solid green. Okay? Cool. All right, so all that looks okay, so I'm going to go ahead and hit. So now, because he's using one, remember it says right here, move probe to phase A and press F6 to start the test. So we're going to find out if we're on phase A. Possible polarity reversal. All right, so we're going to hit continue.
Okay, now remember what we just went over polarity reversal, so we just went over how to position the high volt probe. So I should feel pretty confident that he's got it in there the right way. But I'm seeing polarity reversal. Now what have we said over and over on these webinars? If you get one error message after another, that's usually indicative of something. So let's see if that's what happens, because he just told us how to put the thing in there. I'm hoping he's got it in there right, but it's telling me polarity reversal. But remember, there is a situation where it goes polarity reversal, cross phase, low secondary current, low primary current. If it just gives you one after another, we've talked about that in the webinars, that usually keys us in onto one thing, and you're going to see here in a second.
Possible cross phase connection. So what do you typically, when you see the cross phase and polarity reversal and you see one after another, what does that typically tell you?
Typically tells me I'm on the wrong phase.
Yeah.
Most of the time, I'll look at phase error, see how far I'm out.
That's right. And you know what what's happened to me before too with that is it means if the load is really, really light and I don't have enough load, that's also happened to me. It'll give you just one error after another error after another error. And we've talked about it in the webinars. That's when I go, oh, I probably don't have much load. We're going to take a look at that here in just a second. So let me go ahead and hit. I'm going to hit continue anyway. Low secondary input, yeah, it's giving me all of them. So that would tell me I probably have almost none on there. So it's telling me my primary amps are 0.63. That's not good. That's awful darn low. So in my secondary amps, it's showing 0. 0. Now, how often do you see 0 on the secondary amps?
Not much.
Not much.
Something's going on.
Something's going on. To me, I'm just telling you what I'm, my pea brain, I'm saying that's a disconnect versus just light or a bad connection or something. Wouldn't you say that?
Yeah.
I mean, you'll get something on the secondary. It might be 0.00 whatever, but zeros? Okay. So let's go ahead and we'll move it. And there's another indicator. See when my ratio is just off the scale? Crazy number.
Okay, so you see we're getting this crazy high number here. So let's think about this for a second. If I'm doing a ratio, I'm comparing my primary to my secondary, right? So it's 400 to 5, 400 over 5. So in this case, I've got my primary is 8.63 over 0. If we remember back from math class, if it doesn't hurt our heads too much, if you remember, if you divide anything by 0, what happens? It goes to infinity, right? So I had this question asked to me at a meter school, and I, of course, as usually works with me, I always think of the answer after I've already, it's past time. So we're out in the parking lot talking. I go, oh, man. So, but someone had asked, what about a lightning strike on a CT? If you get a lightning strike on a CT, what would you expect to find? Well, if you think about that, if it smokes those little secondary wires, what's it going to smoke? Or those little bitty secondary wires, it's going to smoke them. Now I got what? 0 on my secondary. So I should expect to see a very, very, very high ratio, right? It starts heading towards that infinity number. And that's what it did here. Okay, so it would be the same thing if you had a lightning strike at a CT and it smoked your secondary. If I smoked my secondary wires, then now I got 0 on my secondary, and I'm going to have the primary. So what's going to happen? It's going to get very, 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 very high. So that's what happened here. That right there, when you see 0, remember now, you should get something through there. Remember when you leave the shunts on a CT, what happens? You get something trickle through there, right? Let's think about that. So if I leave the shunts in, because if you've ever been to a site, and I have, where you've tested, and all the shunts have been left in, and you got bad news to give people, well, guess what? You don't get 0, right? Because that site was running, it was being built, and it's been that way for years. So when you see 0, that's a disconnect in my mind, because something's going to trickle through if you've got any kind of primary. So now that Rolodex is started, right? I'm sitting there thinking, I've got some sort of a disconnect between my primary and my secondary. I can read primary current, and I see it, but I'm getting 0 secondary current. That's telling me some disconnect between my primary and my secondary. And knowing what's inside that can, it kind of lets you know where you probably think the problem is, because think about where I'm making my connections in there. So, thanks.
So to me, and then you look at my phase angle error, is showing 105. So let's go ahead and move it. So move it, we'll hit it again. There we go. All right, let's try this now. So we're going to hit it again. Here we go again. I got cross phase, low primary. I got a ratio of 0.24, because now it's showing me a primary of 0.01 and a secondary of 0.19. And it's showing a phase angle error of 124. Okay, so let's try what you think is C phase. Let's give C phase a shot. There we go. We got both of them on C phase. So let me ask you a question. At this point, would you say, okay, maybe what I should do is I should start the test over and leave it there, and maybe that's A phase versus, since you don't know which one's which? Would you do that?
I just run through and see
okay.
What kind of results you get.
Okay. So it's doing the same thing, polarity reversal.
Just real quick, we talk about this. We talk about the determining which phase is what up there with using the high volt probe, because you look up there and you can't see anything. Everything's worn off, can't see, you don't have any labeling. So what you do is, if you put it on, we know where B is. So we're going to grab one of those outside ones, and we grab that outside one and we hit the button. If we get cross phase, and that's all we get, we don't get all the other error messages thinking that we got too light a load. If we get just cross phase on there, then it's just me. I just immediately go over to the other outside phase, and then I just hit retest, and it should then tell you that you're on A now. You were on C, but now you're on A. Very rarely will they not be. It won't be on the outside. Every once in a while, I've had that happen too. But most time you can think B, center, and the A and C on the outside.
Low primary, so I'm getting 0.33. So it's giving me 0.01 primary amps and 0.15 on secondary amps. So I'm getting almost nothing on there. I tell you what I'm going to do. I'm going to restart. I'm going to move it up to the top and retest just A phase. So I'm going to move my gold box up to the top here, and I'm going to retest just A phase. So I'm going to hit retest. It's giving me possible polarity reversal again. Possible crossfade. It's giving me all of them again. It's giving me a fail again. Now this time it's giving me, again it's giving me 0 on that A phase again for my secondary amps. So if I'm looking this side.
So we followed the process to be able to determine the troubleshooting, right? In order to try to determine what's A and what's C phase. The only problem is the load is so light and we got other problems here that I can't really determine what it is because it's giving me all the messages. If it had just shown me cross phase, then I'd have known I was on the wrong one. But unfortunately, because of my load and issues I've got in that can, it's not giving me, I can't get a proper reading on which phase is which because right now the load is so light it's giving me all the error messages. It's not just giving me cross phase, it's giving me low secondary, low primary, and polarity reversal.
So I'm thinking to myself, okay, you don't see 0 on secondary amp. I mean, there's something. So to me, there looks like there's a problem. Now remember what Browlin pointed out in the very beginning of the issues down here with the test switch and stuff, okay? So if you're getting 0 on the secondary amps, you could have some problems with the test switch to the point where you're actually getting a disconnect there, and we might need to look at replacing that test switch, wouldn't you think? Yeah. Getting that test switch in there replaced. So if we replace that test switch in there, I would say that'd probably be step 1. That's what we'll do. So we'll go ahead and look at replacing that test switch and seeing if we can get some better readings there off the test switch. Now we also have another factor to consider here, which is we don't have much load at all at this facility. Okay, that is a consideration, but I would say when I see 0 on that secondary side, that's pointing out to me, and plus from what we pointed out between the rocks and the ants and everything else, I would say probably what we might actually consider, let's think about doing this, maybe we jump her across there. If we jump her across that test switch and then put a clamp on there, we ought to be able to read the current and see if it's making it down from there to here versus there's a problem just at the test switch. What do you think about that? Yeah. All right, so why don't we do that? We're going to go ahead and run a jumper from top to bottom across there, right? We're going to open it up. We're going to see if we get some current going top to bottom, and maybe that could be the issue. So stay tuned. We're going to do that. We're going to take down what we got right now, but we're going to open stuff up, and we're going to run some jumpers across there and see if we can get a better reading.
Okay, so talk about this all the time. That the meter techs, that we're the eyes and ears of the utility. We see these sites all the time. So we're the ones that are going to have the knowledge of what's you know, the age of the site, which model test switch. Notice there was different test switches. That old style test switch, not, you know, had a lot of issues with it. We'll just put it that way and move on. So all of those things taken in there, this is what happened. We started to do the jumpers, and then our guy there said, well, I can tell you right now because we have issues with those, and that's why we're changing out all those test switches when we come to them, is as we're going in and testing these sites, we're changing out those test switches. And so knowing that, we didn't need to do the jumpers. But I do want to throw that out there as a great, if you had a new test switch in there, I would definitely do the jumpers, okay? The jumpers are a great way. So you see what I'm doing, right? I'm just making sure that when my incoming and my outgoing, that it's not actually in the blade somewhere, okay? So in other words, if I get a jump and I come right across top and bottom, and I get a flow there, okay, and everything's fine, but then when I take the jumpers off of there, right, and I close everything back in, then it doesn't pass through there, then there's a problem right there between the switches and the connections at the switches, right? So if I can open it up and I get a flow through there, I know it's coming in the top, I know it's coming out bottom, I know I've got flow, but I'm caught up by that handle and I'm caught up by that blade, then that's where my problem is. And actually, you're going to see here in a minute exactly what I'm saying, and that's that knowledge of the switches. It's the knowledge of what he's got around there. Our guy said, I think I can tell you what the problem is. We need to change that switch out. We're going to look at the switch after we change it out, and you'll see exactly what he said was true. So it's almost like going somewhere to go hunting or something. You're going to ask the local guy, right? You're not going to just walk out there and just start looking around and start hunting. So he knew. He said, no, we've had issues with these test switches. We've been changing them out. And so as soon as we got that thing out of there and looked at it, sure enough, and we're going to point them out here, you'll see the problems.
So this is typical of field testing, right? So we got a couple of issues really we're dealing with here. Number one is the light load. To which you saw a minute ago when we were looking at the screen, I've only got 6 primary amps and I've got 0.06 secondary amps. And so when you get 0.06, Bryland's typical number, what do you say, 5? You like to have at least 5?
Half an amp.
Half an amp, excuse me. Yeah, half an amp. So you like to have at least 0.5. If he gets 0.4 something, he might give it a run. But if it's much less than that, he's not going to fool with it, because it's really tough to get a good test, because we know how CTs perform on that low end, right, with no load on them. And the machines are the same way. They do not like to test them if there's no load on there. So, so what we're going to do is we're going to go ahead and change out that test switch, because we also know we got issues there. So first we'll change out the test switch. Our primary jumped up to 20 for just a minute. You could hear something cut on in there. So, so they were actually using something for a minute. Maybe they're sandblasting or doing something. So we're going to change out the test switch, and hopefully we'll get a good, if we get a good load at that point, we should be able to test something. But we got 2 issues, so we'll go ahead and attack one of them, which is changing out that test switch where we know we got issues, and then we'll hopefully get a little bit better load to run a test after that. Okay, so what we've done is we've changed out the test switch. You can see it's a new test switch. JP's got some good pictures of it. Also cleaned really well back there behind the meter. One thing that you might want to this is just, you know, FYI, greasing up the stabs and everything on the meters. I know initially it's great because it feels like they're going in and out real easy, but you got to remember you're trying to, you're trying to run current through there and conduct current. So it doesn't really help with that. Then after a while that stuff hardens up. So what we found back behind there, and you'll see it in JP's got some good pictures of it, it also just collects anything that's going to grab onto that grease. So we had big wads of stuff back there and the stabs and stuff too. So it's just not a great general practice to use that grease on there, okay? They got other spray cleaners and stuff that you can use, all right? So we've got it all, you can see so we're going to connect back up again. You guys saw us connect up the first time, so we'll cut away when we do that. But we're going to go ahead and just connect everything up, and we're going to run the test again. You can see right here, this is the test switch we took out of here. These are just some details that we want to point out to all our Powermetrix family out there. You can see this one, you can see this blade going in on this shunt. You see how tight that is where it hits right there and it goes in there? So it's grabbing on that blade right there. Let's go over to this one over here. You can see when this one goes in, there's a gap there. You see that little gap right there? So it's not a really good closed in really well on that one. On this one right here, that one it closed in really well. So that's just another thing. This is the one that we took out. You can see where we had a lot of crud and stuff back there. So this was the one that...
So this is when we were talking about, remember, the ants, you could still see some of the ants left. So there was 2 big wads of ants. We had grass and the rock stuck in across the top of this test switch. But exactly what we were talking about, you could see the gaps in there when this thing, even when I closed those blades all the way in, you could see where there's still a gap on the side of it right here, so it's not making that good connection. So remember, if I had jumper top and bottom, it would have worked fine. And then if I take the jumpers off and it doesn't work fine, then I've isolated my problems right here, right? And sure enough, you can see here where on some of these blades right here, it's actually not making contact on one side anymore, okay? So there's your problem. I've got a disconnect between top and bottom on my test switch, right? So that's what you look for. So if I jumpered it and it worked, then that would pinpoint my problems right up in here. Now let's take a little closer look at it and I'll find it, okay? That's why previously on a web, you saw us working those blades a lot, and we kept working those blades. This is the reason right here, okay?
Changed out. Another thing is it makes it really hard for testing. You see these tabs, the way these tabs are? Honestly, you're better off when you're trying to use those easy hooks. It's very difficult to get on this tab and this tab. Look how thick they are, and there's no holes if you use that easy hook, right? So in these right here, honestly, you're better off getting some alligator clip jumpers, and we can provide those for you, because then you can get a good grip on both of them. It's really hard to get those easy hooks on a big, thick tab like that that doesn't have any holes in it. So just, you know, if your utility's looking out for you a little bit, they'll get you some switches that have the holes in there so you can grab with easy hooks real good. If not, you know, just get a hold of us or whoever you're using and get them to give you some jumpers that have alligator clips on the end of them, because that's the way it would be best to use on a test switch like this, going from here to here, all right?
So remember the time I told you old dog, new tricks. So this was our second site, right, that we did on this trip. And this is when I saw Brown was using and he got on the blades, right, with his alligator clips. And so I noticed here, another reason why I don't like, I'm not a fan of these old test switches like this is, with those big handles, the way they did them in that eye shape like that, it makes it a little bit more difficult to get on the blades. But this would definitely be a spot with those big tabs, those big chunks of metal right there they've got there. It would be a lot better if you actually got on the blades, okay? So this would be one of those times that you would want to get on the blades on this one, all right? So you can see it's not making it very user-friendly for us with those hunks of tabs and making that the big handle on there to cover up that blade. So yeah, not a fan.
Using those jumpers like we do. So we have gone ahead and we're retesting now. Browland's hooked everything up with the new test switch and the new cleaned, we got everything cleaned up really well. So, so we're just over here running the test again. We're going to run that integrated site test. We're going to run customer load on the meter. Then we're going to do the test CTs, right? This time, did you go 30 seconds or 3 revs? So we went 30 seconds or 3 revs this time since we have such a light load. Otherwise, JP's going to end up with arms like Popeye holding that thing up for about 2 hours. So you'll have Popeye forearms, man. All right. Come on, pulse. Better in shade.
Yeah.
These are the times we talk about, right, where that's another thing you take into consideration is how long it takes to get a pulse. Notice how long it's taken to get a pulse here. So that tells you there can't be very many watts are being produced. So something's going on, okay? Either there's nothing going on there, which is why the load is so light, or there's an issue. So you have to take all that into account because remember we're dealing with an office over here off the side of the place where they're cutting. So they got a couple of things they do over there, maybe sandblast stuff, but mostly it's offices over there. So we didn't hear much noise out of there at all. When we heard a noise one time, it kicked up a little bit for us, but you'll notice how long it's taken.
.04. Live with that all day. 0.04 over 100. So, so the power company's getting into them.
So you notice that it gave us only one pulse in the 30 seconds. That tells you that it was definitely a light load, right? So it was 30 seconds or 3 pulses. Well, it went through an entire 30 seconds to get the one pulse.
High volt probe back up there again, and we're going to give it a shot. So we know that, once again, notice the solid green and the 2 open circles because we know we got to move it from A to B to C. It's going to tell me to move it to phase A and hit F6 like it did before. So when he gets it on it there up there, I'm going to hit F6 and we're going to see what happens. And hopefully we'll be lucky or God will smile on us and we'll get a little bit of a load in there. Browland said when he was looking at it a second ago he had 0.5, didn't he? Son, I hope it's that. Got it right where they cross right there. Get them both deep up in there. All right. You ready? Let's give it a shot. So we're going to try it. One time, baby. Let's see what failed on us. We've got Looks like we are 4.6 out, so we are 4% out on the ratio test, and the phase angle error is only 0.349. I don't see that as an issue, but we're still out a little bit as far as instead of 400 to 5s, which they are, we're at 418.7. Okay, you want to try that? You want to, let's see, I don't know if you want to try moving it. You want to try moving it to a different spot and retest it, or we just want to go to other phases and see what we get total? Do what?
Go right there, retest.
Retest it again? All right, let's try it again. We're going to retest it right here. It's 5%, so it's saying consistently around 4 or 5% out.
Secondary current.
Ah, yeah, let's look at that secondary current. Secondary current is only 0.37. So you're not going to get much better than that with only 0.37. But we're not getting 0, which is a lot better, right? So let's try it on, you want to try B phase now? Let's give it a shot. Ready? All right. How about that? A pass on B phase. All right. Let's go to C phase. And that is shocking the heck out of me because we only have 0.2 on the secondary on B phase. That's unusual, but we'll take it. All right, let's try C phase. Pass on C phase. Want to try one more time? We know how we are. We want to try and get all 3 passes. I will say, if you remember, we had our vectors and everything look worse on A than anything. Let's see if we can get. Ah, look at him. Getting up tight on that CT. All right, let's try that now. We're going to retest. I'm going to move my gold box up, and I'm going to retest just A phase. So I move my gold box up to just A phase, and I'm going to hit retest. So we'll just retest A phase. Come on, baby. One time, baby. Man, that's close. Yep, 4.5% out. It's 418. All right. I think that's just with that low a load with only 0.3 on there. We got real lucky on the other ones, 0.3 and 0.2 on them. But 0.3, that's just the nature of the beast. If you can get lucky enough to do it, you can. But I would sit on a site like this, I'd probably consider a load boost, wouldn't you, Brian?
Oh, without that.
I would do a load boost for sure on this one. So that's where we talk about if you have too low a secondary current that you're trying to deal with these CTs, we always talk about you want to load CTs up. Well, in this case, unfortunately, we just don't have much load going on. For just a minute there, they had something cut on. We could hear it over there in the facility. And when they did, we got up a little bit higher, almost to a half an amp on the secondary. But now we're like 0.2, 0.3, somewhere in that range. So, so the equipment, sometimes it'll work for you that low, but most time it's just not a general practice, you know, for you to have it that low if you're trying to get a good test, okay?
So we tested B and C phases after changing out the test switch, cleaning everything up really well. You could see how nasty it was and all the stuff that was back there and changing out the test switch. Then B and C passed. Still didn't have the load that we would like, right? But they did pass. So here's what I would say. This is exactly the situation where you would do a load boost test. Okay, so I've got a light load, lower than I really should test at, to be honest. I've got B and C coming in okay, so I should feel okay about B and C. With that light a load to still be that accurate, I feel good about them. But A phase, I would want to get definitely want to get a load boost test on that and make sure we're okay with A phase CT. It may just be time to change that CT out. But the thing is, B and C I feel okay about. A, I still would like to get that load boost test, so I'd go ahead and load boost test all 3 phases and just check it out. Then I would know for sure on them, because that is a light load. It's going to be a light load site all the time, so you may as well just go ahead and load boost it. That's what I would do on that one.
Hey, John.
Yes, sir.
Speaking of load boosts,
Okay, the subtle segue. Speaking of load boosts,
we
and
should
then
do this for a living.
we should do this. Y'all just didn't see it. A big finger. He just took his finger, went "Burr," and just pointed at it like, "Hey, I just noticed September 28th. Look at that. We're going to be going over load boost benchtop testing. Unbelievable. It was like they knew what was going on.
Like we planned it.
It's like we planned it. Yeah." So register now using the button below the video player. It saves me having to delete all those replies.
And it saves you from getting 100 emails.
Yes, it saves you from getting 100 emails from me. I get wore out about that. I'll have guys come up to me at all the meter schools. How many more emails you going to send me? I'll say, well, start answering them or watch the video. Webinars and that. Yeah, then they go, oh, okay. That shuts them up pretty good. So we'll start watching them. And then oh, yeah, okay. No, we really do appreciate everybody that's watching these things. If you have any, like I said, any requests for prayer, any requests for anything you want us to do, just any requests on anything you would like for JP and I to do here differently or show you or anything like that, if you've got anything, just send it in to us. JP looks at all this stuff, so we'll go through all of it, and if we've got some requests, we would love to do it. Anything that has to do with any of this, we're on it, man. We'd love to do it. So we just appreciate you guys. Thank you so much for tuning in. Thank you for all those great comments out there. And most importantly, be safe. Be safe out there, okay? So God bless.